So hi there all. My topic for today is types of addressing mode. Okay. Um, yeah. So what is an addressing mode? Addressing mode refers to the specification of uh, the location of data required by an operation. Okay. So when the processor wants to do some computation or do some manipulation on the with the operand, it has to find the data either in the memory location or in the register or anywhere else inside the computer. Okay, so when it has to find the operand, it has to follow some techniques. So to find the operand and to keep in track of where the operand is present, it uses something called addressing method or addressing modes. So that is what it's all about. Yeah. So we'll move to the types of addressing. So next is the types of addressing modes. The types are immediate, direct, indirect, register, register indirect, displacement, and stack, yeah, etc. So the first one is immediate addressing instruction. Okay. So in this method of accessing the operand, the processor, when the processor implements this method, the instruction which holds the opcode as well as the operand does not need to search for the operand uh, operand in the memory in any memory location or in registers, because it is present within the instruction. So the processor job gets easy. Yeah. So one example for this method is add 5. So if I tell add 5, the accumulator adds the content 5 to the accumulator where 5 is the operand. Yeah. So one more example for this method is CMA, which is called as the complement accumulator. So which basically complements the content present in the accumulator. Okay. So we can notice that we are not using any sort of register or any memory locations. So that is what immediate method addressing is all about. Yeah. So the next is direct addressing method. Okay. So in this, as the name itself implies, direct addressing, the accessing of the operand happens directly. Okay. So when the processor implements this method of accessing the operand from the memory location, the instruction first holds an address, and that address points to an address in the memory location. At that particular location, the content or the operand is present, such that when the processor uses this method, it can access the operand. Okay. So the address field contains the address of operand. We all know that an effective address is equals to address field. Okay. So for example, add a, the contents the it adds the contents of cell a to the accumulator. Okay. So what are present in the a is added to the accumulator. So that is what direct addressing is all about. Yeah. So the next is indirect addressing method. Okay. So it is the opposite of direct addressing method, where when the process implements this method, it can access the operand indirectly, and it is kind of complicated for the processor to access the operand, because the instruction holds the address. That address holds one more address. That particular address points to one more address where the content is present. So it is like using two addresses to find the ultimate destination. So when the processor implements this method of accessing the operand, it becomes a hectic job for the processor. Uh, yeah. So that is what indirect method is all about. Yeah. So for example, add a add uh, it adds the contents of cell pointed by contents of a to the accumulator. So that is what indirect method is all about. Yeah. The advantage are large address space. Yeah. So as we all know that we have large address space, and there's one address present in the instruction, and there's one address present in the memory. So we use two addresses. Yeah. So the disadvantage is it uses multiple memory access to find the operand. Yeah, as we know that. So it leads to a slower processing of the instruction. Yeah, so that is what interact method is all about. Yeah, so the next is the register addressing method. Okay, so we were dealing with the method where we used addresses to find the operand. Okay, so in this register method, we access the operand using some particular registers. Okay, so in this method, the instruction has the instruction which holds the opcode as well as the register address. Yeah, it also has a name called R there, which is the register name. So it finds this particular R register in the CPU, and yeah, so when it finds that particular R register within the content is present. So when the such that the processor can access the get access to the content using this method. Yeah. So yeah, operand is held in the register name in the address field, as we all know that. Yeah. So the advantages are very small address field. Yeah, as we all know that it's kind of easy, but it has only one address field pointing to one address where the content is present. So it is kind of yeah, shorter instructions and faster instruction fetch. Yeah. Also faster memory access to operands. Yeah. Since there's only one memory used, so we can access to the operand as soon as possible. Yeah. So that is what register method is all about. Yeah. So the disadvantage for register addressing method is it uses very less limited address space. Yeah, as you all know, we have only one address space there. So that is the disadvantage for this method, this mode of addressing the instruction. Yeah. So the next is register indirect addressing method. Okay. So this is somewhat similar to what we studied, what we yeah, studied few minutes ago. That is the indirect addressing method. Okay. This is somewhat similar and same as the indirect method, but there we use address as uh, for the processing of the instruction. In here we use register to store the operand temporarily and get access to it. Okay, so in this particular method, the instruction holds the opcode and the register address. Yeah, so the register name is R. Okay, so it finds the register R in the number of couple of registers present in the CPU, where that is basically a pointer to the operand. Okay, which is also an address to the address which is pointing to an operand present in the memory. Okay, so when points there, it get access to the operand. Yeah, so yeah, this is also a kind of complicated process for the processor to access the operand. But yeah, so one more thing here. Yeah, yeah, the last second one is displacement addressing method. Okay, so in this method of addressing the operand, when the processor implements this method of addressing the operand, it first, yeah, so instruction which has the register R and address A, which is basically uh, a register which holds the address, and that address is the pointer. So that content and the address A's content both are computed, and thus it forms a physical address which is mapped in the memory to find the operand. Okay, this is somewhat an complicated process compared to the indirect and the register indirect method of addressing the operand. Yeah. So yeah. So in this displacement addressing method, it holds the address field holds two values. The address field holds two values. That's something about the A base value and R register that holds displacement value. Yeah. and it also has three versions which we meant, which are relative, base adjuster, and indexing. Okay, so relative addressing is a version of displacement addressing. Okay, so the second one is base register addressing. So it is basically, it's a version of displacement addressing. It is more of a generalized relative addressing where other registers can play the role of a PC. The last one is the index addressing. Okay, so it is a version of displacement addressing, very similar to base register addressing. Yeah, it is somewhat similar to the base register addressing, because they both, those both share the same properties or something. Yeah, so thank you all.